Hey, all right. So I am going to do a very brief rundown of organic chemistry since you have these full slides in your notes. This is page number 31 in your notes book. All right, so page number 31. All right, so let us get started. I'm going to see about switching into my tablet mode. No, I don't think that's going to work. So my handwriting is going to be pretty bad. All right, so organic chemistry. What is it? It is the study of compounds containing carbon and hydrogen. Right, so carbon is the key force here. So remember, carbon has 4 valence electrons. Remember, the valence electrons are whatever those last electrons are. And it always forms 4 covalent bonds because, right, it is a non-metal to another non-metal. So these are only covalent bonds and always going to make 4 covalent bonds. Because if we were to look at the periodic table, it is 4 hops away from being a noble gas, right? So in order for a stable electron configuration, it needs to have 4 bonds, 8 valence electrons. So each of the 4 bonds are 4 single bonds, right? So then that's, right, CH4. So I'm just going to do that. That's CH4. And we're going to say that is sp3 hybridization, or we call that a tetrahedral. So the only geometry that you need to know is that the 4 bonds in a hydrocarbon form the shape of a tetrahedral, right? Tetra meaning 4. So it's basically a 4-sided pyramid. And don't worry, you don't need to know what sp3 hybridization means. That just means 3 plus 1. It means 4 domains around the central carbon. If you go on in chemistry, that's more college level. All right, so it is going to be symmetrical, which is nonpolar, right? So symmetrical in more than one, right? Symmetrical means nonpolar. That means the symmetry of the electrons around the central atom. And we can have a double bond and 2 single bonds. Don't worry about this, right? We're just showing that there's different configurations that don't worry about this, right? And we can have triple bonds and double bonds. So basically, carbon can do a lot of different things, and it's going to be able to make a lot of like long chains and other kinds of shapes because of the 4 bonds it can make. And it can make double bonds, single bonds, triple bonds. All right, so then remember, each dash in a structure represents a pair of shared electrons. Remember, that is a pair of 2 electrons. All right, so types of carbon bonds. We've got our carbon-carbon bond, right? That's a single bond, right? That's 1 pair, right? That's indicating 1 pair of electrons. We have a carbon-carbon double bond, and that's 2 pairs of electrons, right? 2 lines is 2 pairs, 4 electrons. And we also have a carbon-carbon triple bond, right, which is 3 pairs or 6 electrons. All right, so what are the properties of organic compounds? The properties of organic compounds are the same properties as covalent, oh, such terrible, so covalent compounds. I'm going to get rid of the stylus. Okay, so most are insoluble in water, right? Remember, they are nonpolar. Only polar molecules are soluble in water and ionic compounds. So since these are covalent and nonpolar, they are insoluble in water. Right, so the nonpolar molecule of an oil spill, right, is not attracted to the polar water molecules in the ocean, and this is why oil does not dissolve in water. But like dissolves like, so nail polish remover, right, is going to be able to remove nail polish because both are non-polar, right? Nail polish is non-polar, and so is the nail polish remover. Most covalent compounds do not conduct electricity, so we say they are non-electrolytes. Organic acids are weak electrolytes. So in our next unit, we're going to talk about acids and bases, and organic acids are very weak electrolytes. Right, so organic compounds have low melting points, right? They melt easily. So candles, for example, paraffin wax is a covalently bonded organic molecule with a very low melting point. And as chocolate is also a very low melting point, is also a organic compound, right? And it has those weak van der Waals forces, right? Weak intermolecular forces. So now organic reactions, right? Those are chemical reactions that involve organic compounds, right? Compounds containing carbon and hydrogen occur slower than our inorganic reactions. Remember, our inorganic reactions are the single replacement, the double replacement, synthesis, decomposition. And you need a high activation energy. When we get to our kinetics, we'll talk about activation energy, right? That's the energy needed to start a chemical reaction. So the main focus of this section of notes is going to be hydrocarbons. Hydrocarbons are compounds that only contain carbon and hydrogen. If it has any other element present, it's not a hydrocarbon. So a homologous series is a group of related compounds with similar structures and properties. So notice that's going to be the title to table Q in your reference tables, because we have 3 different homologous series, right? Table Q has this as the title. So each member of the series differs from an adjacent member by a consistent number of carbons and hydrogens. So this is where we combine our tables P and table Q, right? Table P tells you the number of carbons. Table Q tells you what series are you belonging to, alkene, alkyne, or alkyne. So there's a 4 homologous series. We have the alkanes, which are single bonds, single carbon-carbon bonds. We have the alkenes, and it has a double bond, and all the rest of them are single. And then we have alkynes, where there's a triple bond, right? So this is basically what we also have on table Q. You should have your reference tables out so that you can examine your reference tables while you look at the PowerPoint. So the alkanes have single bonds, right? Because on table Q, the example has a single bond. The alkenes have a double bond because the example on table Q has a double bond. The alkynes have the triple bond. And then benzenes, don't worry about that. And aliphatic, we're not going to worry about that. And we're not going to worry about aromatic, but an aromatic has ring structure. And anything aromatic, the word aromatic has to do with smells, right? So all smells usually are organic compounds. The aromatics really come into play in the perfume industry, in the makeup industry. So for alkane, alkene, and alkyne series, they're named by the number of carbons in the longest chain. We call that the parent chain. So the number of carbons goes with the prefix. So one carbon has a prefix of meth. So organic chemistry is like decoding a foreign language. If I see one carbon, I'm going to use the prefix meth. If I see 2 carbons, and it's all about counting those carbons, eth, prop, but, pent, hex, hept, oct, non, dec, right? These are all on table P of your reference tables. You don't have to remember those. So now you do not need to memorize, right? Because your table P has them in your reference table. So then this prefix is going to combine with an ending. With an ending. Either it's going to end in A-N-E, E-N-E, or Y-N-E. So A-N-E is going to be a single bond. The E-N-E will be a, double. And then the Y-N-E will be a triple bond. And why do I know that? How do you know that? Table Q. So we're combining tables P and Q. Table P gives you the prefix. Table Q gives you the ending. You put those 2 together, you've got yourself the name of an organic compound. And don't worry about most elephants preferred buttered peanuts. Don't worry about that. All right, what is the total number of electrons shared in the bond between the two carbon atoms? The question's asking about that. 6, because it says total number. So if it were pairs, that would be 3 pairs, but not total number of electrons. Careful, always read carefully. All right, so what is the total number of shared electrons in a molecule? So that's this whole thing. That's a molecule. This is referring to specific bonds. Question 41 here is asking about the molecule. So I'm looking at all of those lines represent 2 electrons. So there's a total of 22 electrons. Okay, so that wraps up our first section of hydrocarbon notes. And I am going to stop our video, and I will do that as soon as I go over really quickly table P and Q. All right, so here on table P, I'm going to do my markings here, right? We've got our prefix, right? Here's our prefix, and then here's this homologous series. So when I take the number of electrons, I am going to take, let's do, I'm going to just do 1. I'll do 1, 2, 3, and then I'm going to put my 4 bonds around it. H, 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 and H. Okay, so here I have single bonds. So since there's all single bonds, then this is going to be an alkane. And now I want to give this a name. So in order to name it, I take the prefix, which is the number of carbons. So there's 1, 2, 3, 3 carbons. So 3 carbons is prop. So P-R-O-P. And now I'm going to take the ending that goes with the single bond, right? Single bond right there. So then single bonds end in ane. Alkanes end in ane. So then A-N-E. So that's propane. So now if I do something a little bit different, and let's just do a little bit of an erase here, if it'll let me. It doesn't want to let me. Oh, here we go. Okay. All right. So I'm going to put in that carbon, and I'm going to put in a double bond here, and then I just need to erase that. Okay. So now I need to rename this. So I have 3 carbons. So I still have prop. So I'm just going to do prop. And now I have a double bond, right? So I have a double bond present. So now the ending is going to not be A-N-E, but the one with the double bond ends in E-N-E, E-N-E. So that's propene. Okay, so that's just a brief summary of Organic Chemistry 1. And in our next set of notes, we will focus more on drawing and naming